How's it going, guys? It's Mr. Canada. Today we're going to talk about the third section of sequences. Specifically, our main focus is going to be talking about geometric sequences. Today what we're going to talk about is we're going to talk about the different parts of the formula of a geometric sequence. We're also going to talk about how we can use the formula to find the terms of the sequence. And then finally, we're going to learn how we can actually write the formula of a geometric sequence. So just like before, what we want to kind of do is recap what we already know about geometric sequences, and then from there, talk about how we can start using the formula of it, okay? So let's go ahead and recap what we already know. From the first sequences video, we know that geometric sequences deal with multiplication. And one important thing is that the common ratio tells us exactly by what number we are multiplying each time to continue that number or to continue the list of numbers. And then the biggest thing that we learned about is if you're having trouble finding that common ratio, what you could always do is take the first two numbers of your sequence, divide them, and then whatever the result is, that's going to be your common ratio. So let's actually look into what the actual formula looks like for a geometric sequence, and it's going to be the following. So notice that it actually is similar to the formula that we saw for arithmetic sequences, but there's just one key difference. So let's go ahead and recap what we already know. So what we already know is this. What we know is that a sub n is what we call the general term. And just like last time, remember that we use the general term in order to find a result for any term that's given to us. So that's useful, especially if they give us a big number. Likewise, exactly like the arithmetic sequence, it also contains what we call the first term. Remember that from our discussion last time, if you're having trouble finding the first term, it's usually the first number in your list. So always look out for the number that's in front. And then finally, just like arithmetic sequences with the tiny difference of the letter change, the letter R here stands for the common ratio. Now again, a recap of that's going to be the number that you're going to be multiplying by in order to continue your sequence. And again, you find that number by taking the first two numbers in your list and dividing them. So a couple of key things here again is that it's very similar to the formula of an arithmetic sequence. Our main goal, like always, is just mainly focusing on where the first term is and how we can use the common ratio to start looking for newer numbers. So let's actually get into some examples here. So for example, let's find the indicated terms of the geometric sequence. So just like before with sequences, what we want to try to focus on is the different parts of the formula. Now remember that when you're trying to plug in anything into the formula, remember that your focus is on whatever the number is for n. So just like before, let's actually work this out so we can get a better idea about how this works out. So let's say that they ask you to find a sub 1, the first term of your sequence. If you want to find the first term, remember that that's going to be the first number. That's number 1. That number 1 is what you're going to be plugging in for n. So from here, this is what you're going to do. We're going to go ahead and copy whatever formula we have up there, okay? 2. Now notice that up here, there's an n up there. That's exactly where I'm going to place my number 1. So this is going to be 1 minus 1. So from here, all you're going to really do here is simplify. So 3 times 2, 1 minus 1 is 0. So if you have a calculator at home, whether it be a cell phone or whether it be the calculator on your computer, you can add exponents into it. Okay, so for example, I'm just going to go ahead and use the regular calculator that I have on my computer just to get a better idea about how we're doing these calculations. So 3 times parentheses. It's super important that whether you're using a calculator on your computer, on your phone, that you include this parentheses, because remember, the calculator is a literal person. It'll take whatever calculation you put in there and it'll try to make out whatever language it is. So that means that if you missed a parentheses and it didn't get you an answer that you were expecting, that parentheses actually mattered a lot. So from here, 2 parentheses to the power of, if you're on the computer, it's this button right here. That's how you put the exponent, to the power of 0. And look, my result is 3. So that means my first answer is going to be 3. Now, we're going to be repeating these steps one by one just to get a better idea about what we're doing here. So let's say that we're asked to find the next one. This time, my number is 2. So that means that when I'm copying down my formula, the number that's going up here is going to be a 2. So that means in this case, this will be 2 minus 1. Again, what we can do here is try to simplify as much as we can. So we have 3 times 2. 2 minus 1 is 1. And again, from here we use our calculator to simplify. So 3 times parentheses 2 to the power of 1. And our answer is 6. So we're going to put a 6 here. So again, keep in mind where we're plugging in these numbers. We're always plugging in the number for the n at the exponent. That's where all the magic happens. That's where all the calculations happen. So let's see it in action one more time. So let's say you have a sub 4. This time the number that we are plugging in is 4. So 3, 2 to the power of, this time like I said, the number is 4. So 4 is going to go up here, minus 1. Let's simplify. So you have 4, oops, no you don't. That's a mistake. 3 times 2, 4 minus 1 is 3. And again, use your calculator to help you out with the calculation. So 3 times parentheses 2 to the power of 3. That gets me 24. So that means my final answer here is going to be 24. So again, keep in mind what's happening. Wherever the letter n is, exactly how we did it for arithmetic sequences, that's where you're plugging in your number in order to find out what the resultant number is. So keep it super simple. If they give you a formula, just take the numbers at the bottom in the subscript, plug it in, let the calculator do the work. Again, pay attention about where you're plugging those numbers in. Let's look at one more example about how we can actually write it. But before we get into that point, let's go ahead and think about what's the best game plan in writing a formula like this. So here's the game plan. If they're asking you to write a formula for a geometric sequence, you're going to be using this formula. You're going to mainly be focusing on this. So there's only 2 pieces of information you have to be worried about. You have to look for the first term of your sequence, and you have to look for the common ratio. After you have those 2 pieces of information, this is the real simple part. All you have to do is plug in those 2 pieces into the formula and simplify. You're going to see that it's actually a lot less work than what we do for simplifying an arithmetic sequence. Let's go ahead and check it out. Let's go ahead and write the formula of the geometric sequence. This one's pretty simple, right? I already gave you the first term, or they already gave us the first term, and they already gave us what the ratio is. So just like before, I think it's a really good idea to write down what formula you're actually using. In this case, we're using the formula for the geometric sequence, which in this case it's going to be a sub n, a sub 1 times r to the n minus 1. Now, is it necessary to put that n minus 1 up there? Absolutely. It is always important to put that n minus 1 up there. It is part of the formula. And if you were to work this out, plugging numbers in, not including that n minus 1 is actually it's going to mess a lot of the steps up when you're trying to evaluate it. So it's important that you leave it in there, okay? So let's keep this super simple. What do we have to do here? Well, they already gave us 2 pieces of information. They tell you that a sub 1 is 5, and they tell you that r equals 2. So all you have to do is do this one simple step. A sub n. My a1 in this case is 5. So we're going to go ahead and put 5 there, right? So then from here, we do times, well, what's my ratio? Again, my ratio is given to me. In this case, it's 2. And then let's not forget this important piece, n minus 1. This right here is what your formula would look like. Plain and simple. You take the numbers that were given to you, you plug them in, and like I said before, you have to simplify, but what's great about this particular example is that you don't have to simplify anything. It's good to go. You can go ahead and do whatever you want with it. Now, is it always going to be as simple as this? Absolutely not. Sometimes you're going to have to look for that information yourself, but it's not that hard. Check this out. Let's write the formula of the geometric sequence. Notice that I didn't tell you what the first term was, and I also didn't tell you what the ratio was. So it's our job now to figure out where that information is on our paper. Now, in this screen, on this particular example, we have the sequence of 4, 8, 16, 32. Now, again, before you even do anything else, I would write down the formula. A sub n is equal to a sub 1 times r to the n minus 1. Now from here, we can look for the information that we want. What information do we want? We only care about the first term, and we only care about what the common ratio is, little r. So now, finding the first term is the easy part. Remember that the first term is the first number in your list. So my first number in the list here is 4. So that one's an easy one. That's already an easy piece of information that you can get out of this. It's just 4. Now finding the second piece of information is where we have to do a little bit of work. Remember that little r is the ratio. And to find the ratio, you can take the first two numbers of your sequence and divide them. So let's go ahead and take the 4 and the 8 and divide them and see what we get. Now, it's important that you get the order right. It's always going to be the second number divided by the first number. So in this case, it's going to be 8 divided by 4. Now again, why are we doing 8 divided by 4? We are doing 8 divided by 4 because we want to look for the common ratio. Now, according to the calculator, the common ratio is 2. So that's saying that I am always multiplying by 2 to continue my list. Now, does that make sense? Well, 4 times 2 is 8, so that makes sense. 8 times 2 is 16. That definitely makes sense. So the ratio makes sense. Now, what if you got a decimal? Well, if you got a decimal, your expectation is that your number should be getting smaller every time. But since my numbers are getting bigger, our expectation should be a number that's bigger than 1, right? It should be like numbers 2, 3, 5, 1.5. As long as that number is bigger than 1, our expectation should be growing, not getting smaller. So, where do we go from here? Well, now that we have these two pieces of information, now here comes the easy part. We take the formula that we already have, and all we have to do now is just plug it in and we're set. So a sub n, we know a1 is 4. We found that right at the beginning of the problem. So this is going to be 4 times, well, what was the common ratio? Again, we just figured that out. We said that little r was the number 2. So 2, and then we just include the n minus 1. Now, is this a whole lot more work than the other one? Maybe a little bit, but really, we're just sticking to the fundamentals. We write down the formula, we look for the first term, and then to find the ratio, we take the first two numbers, we divide them. What if you're still not sure? We'll take the next two numbers and divide them and see if the result is the same. Okay? So, this is how we write the formula of a geometric sequence if the first term is not given to you and the ratio is not given to you. I hope you guys learned something new today. If you have any questions, please let me know. But as always, please take care, and I'll see you guys next time. Peace.